Remember we said that vectors have size and direction? Now I want to focus on the size or the magnitude of a vector. And magnitude is just a fancy way of saying size. So here we have this question that says, calculate the magnitude of the vector AB. So if you're given a vector like this, the first thing you want to do is to write it in column form, right? So to get it in the form x, y, we need to count that horizontal shift. So moving along the x-axis, how do I get from point A to point B? It would be 1, 2, 3, 4, 5. So my x value would be 5. And because I move to the right, it's going to be positive. This is an equal sign here. Good. So now I need to find out how many spaces do I move vertically. So I'd move 1, 2. And because I'm going up, it's going to still be a positive 2. So my x value would be 5 and my y value would be 2. So we're going to use this formula. This is what we call the distance formula, right? To calculate the magnitude of the vector AB. So remember, our x was 5. So wherever I see x, I'm going to put 5. And notice that it's squared. And our y value was 2. So wherever I see y, I'm going to put that 2. So remember, it was also squared. Then I'm adding them, and I'm going to square root everybody. And this symbol is what we use to represent the magnitude of a vector. So the magnitude of the vector A to B is equal to the square root of the x value squared plus the y value squared. So 5 squared is 5 times 5, and that will give us 25, plus 2 squared is 2 times 2, and that will give us 4. Remember, you're square rooting everybody. So we need to work out now what is 25 plus 4. That's 29, and I'm going to square root everybody. So I'm going to have to draw for that calculator and put in the square root of 29, and that's 5.39 to 2 decimal places. So 5.39 to 2 decimal places. And to complete my sentences, I'm just going to write this part down and make it look neat, just like one little paragraph in English, you know, complete sentences. I like that. Good. So what that is saying to us is, if we're supposed to measure the vector AB, we're going to get 5.39 units. That's all it's saying. So this is how we would calculate the magnitude or the size of a vector. What if it looked like this on a coordinate grid? Well, what I would recommend is to write down the points. So let's say, or the coordinates to the points. So A would be located at 1, 1. Good. And B would be located at 6, 3. What I could do from here is to label my coordinates. I could label this as x1 and y1. And I could label this as x2 and y2. Zooming. Good. So I'll be using these inside of this formula to help us solve the problem. So we need our x1 value. That was 6. So I'm going to take 6 and put it right here. And we're subtracting our x2 value, which is 1. So I'm going to put the 1 right here. Look at the thing. Notice that you have brackets there and that's square. So I'm going to have to bracket this and square it. Then the formula says add, so I'm going to add. Right? Then I'm going to need my y1 and y2 values and put them in brackets and square them. When I'm finished, I'm supposed to square root everybody. So, what's the y1 value? Y1 is 3. And the big something says minus. And then the y2 value is 1. You see that? See there? Y2, 1. So I'm going to put 1 right there. And it becomes very easy after that. Right? You just do the math. So, the magnitude of the vector AB is going to be equal to the square root of 6 take away 1, that is 5, and I'm going to square that, plus 3 take away 1, which is 2, and I'm going to square that. And you just work it down. So 5 squared is the same as 5 times 5, and 2 squared is the same as 2 times 2. 5 times 5 is 25, plus 2 times 2 is 4. And I need to square root everybody. 25 plus 4 is going to give us 29, and I need to square root that. So now I need the square root of 29. And the square root of 29 is 5.39 to 2 decimal places. So that's 5.39 to 2 decimal places. And to clean it all up, you just write back this. Right? Make it neat and clean. And that's it. Simple cheese.